Okay. So I'm going to comment on the basics of Java here in AnyLogic. Okay. So I'm not sure I included these. It struck me. I don't know that I included these in the list. I will try to do that. Okay. I apologize. But I futzed around there, and I thought I might have included them, but I didn't. Okay. So a few basic points about AnyLogic in Java. One of AnyLogic's greatest strengths is that I've been emphasizing is the fact that it's mostly declarative. That, in other words, it lets you focus more on the what and less on the how. For the most part, AnyLogic, in many cases, it takes care of figuring out the how. And this is in stark contrast to many other agent-based modeling platforms, where you actually have to specify a fairly large amount of code to specify a model. We've seen at this point most of the mechanisms of AnyLogic, and I've got to congratulate you on getting this far. We've seen most of the elements of the AnyLogic vocabulary. There's a few for us left to touch on, things like mobility and aspects of spatial context. But here we've actually seen that much of a model can be specified in a declarative way. We've seen state charts. We will see stock and flow diagrams. There's actually flow charts that you can specify for the model to describe algorithms, and maps, which we'll see tomorrow in terms of situating things. For most interactions with AnyLogic, you'll be able to specify your intentions using these declarative mechanisms. But you will have to write and look at Java code. So there's no question that you're going to be using bits of Java within your system. And we've seen that within our various models. Most notably in this last model, we've added functions, which are none other than Java methods. We've gone and created these events and where we've called off and requested things. We've gone in person and we've specified properties to assume for areas of their of the visual representation, and when we click on them, we said do such and such. Those are all elements of Java. What is Java? Java is a cross-platform programming language that is introduced by Sun Microsystems now, which has been purchased by Oracle, and it's been around for about 20 years now. It was designed to be a system that would run on just about any computer that's out there, and it runs on tablets and smartphones and many other systems as well. It's what we call an object-oriented system in the sense that information about something is sort of bundled together with information about how the rules for manipulating that thing and behaviors of that thing. And in our case, those things are things like agents. So we bundle together the information about the agent together with its state charts, together with its functions, and we can ask, for example, an agent, give me your number of connections, or we can ask it, give me your ethnicity, or give me your sex, or we could tell it, connect me to you, or something along those lines. So that's an aspect of object orientation. We group together things into objects, and a classic object would be an agent. Okay, so the agent maintains information on its state, and it maintains information on its properties, bundled together. Okay, AnyLogic is written in Java, and it turns models into Java, and the little bits of code that you're writing get woven in to the code that it produces. Okay. It has lots of ways to insert snippets of Java code, and it has lots of ways to interface to Java libraries or other code that other people have written, okay? And you're going to need to know something about this if you're going to be building up models or if you're going to try to debug models, etc., okay? So we've seen, for example, in defining custom statistics over a population, or putting into place initialization mechanisms, or exchanging messages. There's bits of Java here and there. Now, the use of Java is notable for a couple reasons. I personally don't think it's the best language in the world to use with a modeling platform. I think there's better choices, but it's not a terrible language, and it has certain strong advantages. One of the advantages of is extensibility. There's a huge number of pieces of software out there that offer functionality in the form of what are called libraries. These are software that will do things for you. An example might be software that will allow you to look up locations in a GIS library, or software that would allow you to find out information on historically observed disease rates over some period of time, or libraries that would allow you to visualize things, libraries that allow you to connect to databases, and libraries that allow you to interface with external software. So one of AnyLogic's greatest advantages is the capacity to make use of these literally hundreds of thousands, if not millions, of pieces of software out there and pieces of functionality that other people have built up. To illustrate this, where this is done in a model, if you go up to the model itself, you can go specify what are called jar files. And these are basically places where you can link into, say, a statistics library. So I could go specify here a jar, which I could go find in my disk. For example, this math library, which I could call. Or here's a database connection library. And those would allow me to, for example, connect to some databases, allow me to perform common statistical functions that are not defined in AnyLogic. For example, certain distributions that might not be supported in AnyLogic. AnyLogic supports a quite broad and rich set of functionality, but if you consider what's available outside of it, it greatly extends what you can do within the platform. In principle, you can make an AnyLogic model that reads things over the network, looks up certain information historically, stores information in databases, and uses GIS systems as a routine part of its operation. This is not it doesn't require a lot of work to do these things, and it's extremely powerful. So in terms of extensibility, there's very, very big implications for using Java. It really, really helps. There's also a set of additional tools that you can use with it. And Priesri in the back here has done much work, as have done some other people in my group, to leverage some of these tools. And we're going to be seeing illustrations of some of these tools in the context of the week. One of them is a profiler, and this will tell you where your model is spending its time, which areas of the model are the bottlenecks, and it can help you identify ways you could speed up your model very materially. Is it spending it in the visualization, and is it spending it in certain parts of the model, and if so, which parts? It also allows you to use what's called a debugger. So the fact that it's written in Java allows you to attach to a debugger externally, which you can use with your model, or use a built-in debugger that's based on the same basic platform, which is called Eclipse. And that allows you to find problems in your model more quickly. And we'll see an example of that. We'll see the use of that later in the week. There's also a set of other functionality you can use. There's a testing framework called JUnit, and there's some mechanisms called assertions, which are also supported within the Java framework. So we'll see later in the week some of these being used, and it's because this thing is written in Java that we're able to use these things. Priesri back there and others in my group have further made very clever use of some functionality associated with Java to do some very sophisticated things we'll be talking about in a few minutes. and they have to do with this basic process by which AnyLogic works. So suppose we have an AnyLogic model, which has state charts and transitions between them. We then have that model in little bits and snippets of code, as we've seen. I pushed you pretty darn hard here. And there's snippets of code woven all through those models, okay? Those snippets of code, when AnyLogic is built, it turns into Java code, okay? This is done behind the scenes. You don't really see it directly, typically. But what happens is if I take a model like this and I were to build it, what's going on behind the scenes is it turns it into Java code, and then it turns it into what's called bytecode, which is something it can run. It can actually execute it. It can simulate it out. But this Java code is there in the meantime, and occasionally you may want to be aware of it. I actually showed an example of that earlier, but let me give an example. There's two ways you could see this easily. One, the more targeted way, would be if you were to go, say, to this immigration event, you would just say, show me what's there. You press Control-J, and it will take you to that point in the code. This is actually the Java code, and it says execute action of a certain event rate. If it's the immigration event, then do this, add the person to the population. You should almost never have to look at the code, but occasionally it's useful to get an understanding of what's going on, or occasionally because there's some problem. And I'd say occasionally, I mean, maybe for me, I use this thing, very, very frequently, and I might need to look at it a few times a year, something like that, maybe twice a year, something like that. Okay, that's with Control-J. You put that, I'll show you a place that's quite useful. People were asking me earlier, how do we know about item? How do we know about sex? How do we refer back to like the value of the sex if I want to determine the ethnicity or what have you? And again, by doing Control-J, that lets me see where these things are set up. I could see we have self.sex equals this here, self.mortality rate, self.ethnicity. If I want to use sex, it can be pretty clear, okay, I can refer to it as self.sex and that it's already been set up here. Again, very rare that I need to do this. I almost never have to look at it, but occasionally it's kind of helpful. That's looking, ladies and gentlemen, at this Java code, okay? That's looking at the Java code. That's one way to look at it. The other way to look at it, which I almost never do, but occasionally to be useful, so if you go to person, you could say open, and that will open, I could double click on it and we'll open this up. Or I can say open with graphical editor, that will be the same area, or I could say Java editor. And this actually shows me the full Java code associated with this. Again, I almost never need to look at this, but you should know that it's there, and that is just an indication of what this Java code is, and sort of in the middle here. Some of these things are pretty transparent. Over the next few days, we'll actually learn to become more and more comfortable with them. I'll give you an example. If you go to main here, and let's go to population. We defined population statistics. We didn't do it in this model. Let me open a model where we did have a population statistic. Say our SAR agent network model that we had earlier today. Here we go. Go into the main class, go into population. Let's go down and look at statistics. Okay? Here's the statistic, count infective. Remember I was telling you that the way this works is it runs through the population, calling each person item in turn, calls the first person item. It checks if they match this condition. If so, it counts them, otherwise not. Goes to the second person, calls them item. Should I count them? Increment count. Okay, ladies and gentlemen, let's see how that actually works. Control-J. You didn't have to depend on me to tell you that. Here we have a bit of code, and over the next few days, hopefully you'll get more comfortable with this code. It loops through each person in the population. That's what this for does. It says for each of these persons called item in the population, then do this thing. And this thing is, okay, it evaluates whether or not their state is active for this person. And if it returns true, then we increment a value that started at 0. Otherwise, we just go on. So this thing at the end holds value, and at the end it returns value. Okay? So this is where our code goes into. Behind the scenes, this is what's going on. Here, each and every person in the population is being processed. Okay? That Java code is then turned into byte code, which we can then run. And for the most part, 99.5% of the time, I don't have to worry about this at all. Occasionally, it will be useful. Okay, so this build button is, as I've said, one of the key elements. And build basically will tell you, does AnyLogic understand what you are saying with the model? If build fails, it's a sign it has no idea what you're trying to do. On the other hand, the model may not be correct. Even if the build is correct, the model itself may not be correct. Okay? A key element that you're going to be using in the Java context is this build, this problems window, and that will highlight for you issues with your model. And occasionally it will plop you into Java code. For example, suppose I were to do something weird here. Suppose I were to do something like this. This doesn't mean anything in Java. Maybe it's a typo. If I press this, it will actually say syntax error, and it will put me back here. In this case, it wasn't too bad. Maybe I can do something that will screw it up terribly. I'll put a semicolon in the middle. Let's see if nope, it's pretty robust for that. I'm trying to get it so it will actually put me directly into the to the code. Maybe I could put this, okay? Hey, it's happy with that. Okay, it's pretty robust. I can't get this thing to show me the trouble, but there will be cases occasionally where there's a problem here, and it will. Here we go. Success. Okay, let's go double click. Oh, come on. Show me the code. No, it's I guess version 7 may be a little bit more robust than this. It's not giving me the problem, but occasionally you'll see the code come up, and you should realize, oh, that's where it's capturing things. I thought we saw that earlier. Yes, it was in one of the students had a problem. Let's go see if we can cause this. Let's make a default value of this parameter be 100. There we go. Yeah, and so here it's actually putting us into the code. Okay, it's saying I don't know what to do with this thing. So population size, instead of giving just a value of 100, I put semicolon, and it's an unhappy camper. It says unreachable code, and it plops me down right here. This is the code that it generated. This is the code that it produced to run the model. But it couldn't understand my code. Okay? So occasionally you'll be forced into looking at that. And just be aware that's the code that's generated, and it's something about what you've done that's throwing it off. And often it will give you an error message that will suggest to you what the problem is. Okay. One thing I will say, and this relates to some of the things that Priyasu will be talking about later in the week in her little lecture to you folks. We've created a number of tools for AnyLogic which actually work conceptually at this level of the byte code. In other words, what they allow you to do is they allow you to take a model and weave in support to automatically do certain tasks so that you don't have to specify them directly. You don't have to specify them in the model here. You can't modify this Java code. This Java code is immutable. It can't be modified by you. What you can modify in the model is over here on the left-hand side. What her tools do, and the other tools like them that she'll be presenting, they basically modify the bytecode to get it to do certain common tasks. One common task will be tracing the model, tracing all the things going on in the model, so you can have a really bird's eye picture of all the things happening in the model. When an agent gets a message, when it sends a message, when it's created, when it's destroyed, when it interacts with other agents in terms of coming into a state chart or leaving a state chart, it can actually report this to you automatically, okay? You don't have to go put in those trace LNs. You don't have to tell it, print this out here, print this out there. It'll report that. Another thing that her system does by modifying the bytecode is it actually, every time you run the model, it'll have a record of that. It will actually create a complete copy of the model, and it will capture the values of all the parameters you used to make that run, capture screenshots of the model before it runs and after it runs, so when it completes, so that you can totally reproduce that run of the model. That, you could come back a year later and you'd have all the information you need to rerun that exact run of the model, which is really useful if you're trying to conduct a project where, you may want to go back to earlier runs and say, okay, what if we had done this? Or if you try to publish a paper and they get back reviewer responses and they say, please change this, and you have to go back and rerun a particular version of the model that you did earlier, that's very useful. So Prehistory will show you tools. Another tool that operates at this level is exporting to R. So there's a tool that will allow you to take an arbitrary AnyLogic model and without writing any code, export the data to R, to the R statistical system. So operating at the bytecode level is possible, and we do that, and we'd be glad to speak with people who are interested in doing that. Okay. A few basic principles associated with this. One thing is when you build, the Java files are stored in a certain location, and it is possible to go find where they're located. The location differs for different types of machines. For a Windows machine or a Mac or a Linux machine, it'll be a little bit different, but they're all stored away. The Java files and the so-called class files produced are all stored away elsewhere. So you can go retrieve them if you want to do so. But for the most part, the Java that goes on is, most of the Java that is produced is fairly invisible to you. You'll just occasionally have to interact with it in the form of these small little bits that you've been entering, okay? One place that this does come up, and we'll see this later in the week, is that you can debug a model. And with debugging a model, you can be placed into this model in a way that allows you to sort of inspect it while it's running. And if you're going to be debugging it, you will often need to sort of know what's going on at a more fine-grained level. And this debugger is something I'll be demonstrating later in the week, but basically you can use it to report on what's happening in the model in terms of variables, what values they hold, for example, the population size or the count of people with a certain attribute or what have you. And by running the model in the debugger, we can actually monitor what's happening while the model's going on at a very fine-grained level. It's like having a microscope. We can also set it so that it'll stop the execution at certain points in the model. Okay, so within AnyLogic, when we have code, we can go and set so-called breakpoints so that when a certain point is reached in the model, it will actually stop running the model at that point. It'll actually pause the model at that point and allow us to go in and inspect what's going on in the model. So within AnyLogic, you're going to have these places that you can insert code, and that code can then be inspected while the model is running, and you can ask ask about certain attributes of what's going on. And I'll be demonstrating this later in the week in sort of a live demonstration on a particular model. So the AnyLogic debugger is something where if you know a little bit of what's going on, it can be helpful for debugging the model. Okay. AnyLogic tries to shield you where possible from Java, and it provides a variety of tools for doing that. The first and most important are these kind of mechanisms that you see graphically, but there's some additional mechanisms. For example, it lets you here choose probability distributions that you want to use and specify attributes of them. It actually, I believe this is sampling from them here with a certain value. So for example, for an exponential distribution, I can specify values, or a normal distribution. And, you know, by changing these values, it'll let me sort of see the values of the distribution. And this may allow me to sort of pick an appropriate distribution for my model. And I'll actually insert the appropriate code for that. So this provides a way of sort of easily picking an appropriate distribution. You notice this random true and random false are specified, but there's many other distributions that are also specified. These are the ones built into AnyLogic. Now, if I go and I add to my model as a whole additional libraries, then I can make use of those distributions as well. So, for example, if I were to go here and add into my model a reference to this Commons Math library here, this contains a wide variety of distributions. And I can make use of them in my model by going and referring to the specific information presented in that particular library. And we would do that through this imports area. I can say what things I want to refer to from that library. We'll see some examples of that. It's fairly, it's a little bit more advanced, but it does allow us to refer to these external libraries. Okay. So the fact that AnyLogic is built in Java is something that's an important asset when using these models. It does allow, in more advanced situations, our models to be used by other Java programs. You can actually package up your model within Java, for example, as an applet. So to do this, we can go File, Export, and we can make it a standalone Java application or an applet that runs in a web browser. Standalone Java application is something that can actually make it run as a whole separate Java program. And we can also package up the model in a way that it could be called by external software. Just a little bit about Java as a whole, and this will be sort of a glimpse of the next few days. So I'm just